Hello, and welcome. My name is Andrea Lindblad, and I am a product specialist with the ArcGIS For Maritime team here in Redlands, California. Thank you for joining me today. I'd like to tell you about ArcGIS for Maritime Charting and what's new at 10.3.1. ArcGIS for Maritime Charting provides simple and efficient tools and workflows for the production of S57 datasets, as well as paper nautical charts from a single source of vector features. This concept of one database to multiple products allows chart producers to increase flexibility of product outputs, as well as increase productivity while reducing the number of edits to the central geodatabase. This production environment can also be used to analyze data using a variety of geoprocessing tools, to visualize data using S52 Symbology, and to share data by publishing web services with ArcGIS for Server. Today's presentation focuses primarily on ArcGIS for Maritime Charting and covers a brief review of the solution and its workflows. These workflows include creating new products, exporting products, editing the authoritative data in the central database, creating updates, and creating paper nautical charts. I will also share a few highlights of new tools at 10.3.1. The format of the presentation will include a short explanation of the topics, followed by software demonstrations. After the presentation, please feel free to send in your questions via email, and we will answer them. For those of you who are new to ArcGIS for Maritime, it is a solution that manages maritime foundational and authoritative data, creates a variety of products from the data, and shares these products. It is a platform solution with two desktop extensions, ArcGIS for Maritime Bathymetry and ArcGIS for Maritime Charting. There's also a server extension, ArcGIS for Maritime Server. These extensions allow users to collect and manage maritime data, as well as create and share a variety of products. The foundational data is essentially bathymetric survey information, as well as vector features for safety of navigation. ArcGIS for Maritime supports creating the following products: S57, including electronic navigation charts, or ENCs, additional military layers, or AMLs, inland electronic navigation charts, or IENCs, digital nautical charts, or DNCs, and paper nautical charts. ArcGIS for Maritime adheres to the International Hydrographic Organization standards for all of these products. Other custom products may also be created from the data and may include the results of a geospatial analysis for seafloor erosion or a dredging atlas. These are but a few examples. In this first section, I'd like to briefly review the ArcGIS for Maritime Charting solution. At a high level, ArcGIS for Maritime Charting solution includes the use of two primary databases. The first database is the NIS, or Nautical Information System. It is a centralized database to store all of the authoritative nautical data. It can ingest S57 or .000 files with the S57 to Geodatabase tool. It can also ingest any other data sources that ArcMap can accept. The data can span a large geographic area and most likely will be at multiple scales. New at 10.3.1, multiple S57 files and their update files can be ingested with the S57 to Geodatabase geoprocessing tool. Since it is a geoprocessing tool, it can import in batch, or a model or script can be written to import data. The second database is the product library. With it, the footprint, scale, and metadata of new products are defined as well as maintained. New at 10.3.1, existing product footprints can be imported into the product library with the PL/AOI Loader tool. Think of the product library as a catalog of all of your products, both electronic and paper charts. In short, the NIS stores the data, and the product library manages the products. In this first demonstration, I will show importing S57 files with the Import S57 to Geodatabase Geoprocessing tool, as well as the PL AOI Loader tool. Here in the Product Library window, you can see I have already defined my Product Library workspace. The Product Library is a catalog of products for both electronic and hard copy products. I also have some data loaded. The data is coming from my NIS. The NIS database can be an enterprise database, but for this demonstration, I'll use a file geodatabase. The data loaded here is 1 to 45,000. I have data for a new product, which is at 1 to 22,000. I'll need to import that data. In the Nautical toolbox in Arc Toolbox is the new S57 to Geodatabase Geoprocessing tool. By opening it in batch mode, I can select multiple S57 files and their updates or revision files and enter them here. The base S57 cells and their updates can be in different directories. Previously, I had to import S57 files one at a time. With the Geoprocessing tool, I can import in batch via a model that I have written. To be clear, only the Geoprocessing tool is included in the box. When using the model I have written, it utilizes the S57 to Geodatabase Geoprocessing tool and imports all of the S57 files in the folder location I select. I also choose my NIS workspace. And finally, I'm ready to run the tool. Here I can see my S57 files have imported successfully into my NIS database. If I refresh my screen, I can see the data appear in my NIS database. Now that I have loaded my data, I need to import the footprints or the areas of interest for those cells so that I can make my products. To do this, I'll use the PL AOI Loader tool. Within the tool, I can select the same cells that I previously imported, as well as choose which product class those footprints will be created. Now that I've loaded the AOIs, I'll view their footprints. By adding the Polygon feature class from the Product Library database, I can see that the area of interest are imported successfully. The AOI feature class stores metadata information necessary for the new product wizard, which I'll demonstrate in a moment. Now that I have my data in the NIS or central database and my footprints or area of interest, I'm ready to create new products. To review, the NIS stores the authoritative data in a central database. The Import S57 to Geodatabase Geoprocessing tool allows you to import multiple S57 files and their updates at one time. The Product Library database is what you use to create and manage all of your products. The PL AOI Loader tool imports the footprints of S57 files and can be used to create both electronic and paper charts. In this next section, I'd like to review how new nautical products are created and exported with ArcGIS for Maritime Charting. Once you have imported your data and defined its footprints, the data is ready for new product creation. This is where you define what type of product you'll be creating, its geographic extent, its scale, and its metadata. This is performed in the product library. This step is really quick and simple as the solution comes with a wizard. The wizard guides you through the process, as I'll demonstrate in a moment. Creating the product is only performed once, as it prepares it for the export process. The new Nautical Product Wizard allows you to define the area of interest for the product, as well as the product metadata. The export process is where the data is extracted from the NIS or central database and converted to the S57 format. This is also quick and simple, as it is also a wizard. The export wizard completes several tasks: reviewing the metadata, extracting the data, and creating the S57 file. For a brand new product, exporting it creates the first edition. Subsequent exports will create new additions or updates for the product. At the end of the process, the S57 file is ready to be distributed. At 10.3.1, this is the first release of ArcGIS for Maritime Server. It complements desktop products. Maritime Server can be used by chart consumers as well as chart producers, as it makes maritime information accessible to all. It provides the ability to publish OGC and Esri REST web map services from S57 datasets and S63 encrypted datasets using ArcGIS for Server. These services are supported across the ArcGIS platform. It works with any S57 data and can operate alongside any chart production system. Maritime Server can be set up very quickly, and it is ideal for initial operating capability. With it, you can add S57 files to a folder, and the entire organization instantly has access to them through a web mapping service. In this demonstration, I will show how to complete the new Nautical product wizard, the export wizard, the S57 file created with ArcGIS for Maritime Charting, publishing the S57 file, marking it ready for public consumption, and sharing the S57 file with ArcGIS for Maritime Server, displayed with S52 Symbology. To create a new product, I will access the new Nautical product wizard in the Product Library window. To do so, I'll select a series in which to create my new S57 product. With the new Nautical product wizard, I define the AOI footprint for my new product. If I'm unsure of which polygons to select, I'll use the Identify tool to verify I have the correct coverage and no coverage polygons for my new product. Once I select them, I move on. My production agency has already been defined, but I still need to choose the intended usage and product definition. I also enter metadata for my product, such as the vertical and sounding datums, as well as the addition and compilation scale. The summary page allows me a second look before the product is created to verify I've entered in the metadata correctly. New at 10.3.1, there's no longer product databases for S57 products. Only paper products have databases. After product creation, the metadata for the product can be viewed at any time in the product library. Here I can view the first edition of my product. Once the product is created, it is ready to be exported with the Export wizard, also accessed in the product library. The Export wizard allows me to define either a new edition or a new dataset. Here I'll choose New Dataset as it is my first edition. I'll also define the output location on my local machine where my S57 file will be created. I also have the option to add any external files, such as text files or pic reps. The Export wizard allows me one last chance to review my metadata, yet limits the fields I can adjust before data extraction. Once more, the summary page allows me one last look before data extraction. The export process is where the data is extracted from the NIS based on the area of interest and the scale of the data. The S57 file is created on my local machine, as well as zipped and added to the product library. I can copy the location of the log file and view it in a moment. In Manage Files, I can view that the zipped file has been created and added to the product library containing the S57 file I just created. In Windows Explorer, I can also view my S57 file has been created at the export location I selected. If I paste in that log file location, I can view the log file to view the data extraction. Once the product is successfully exported, it can be published and marked for public consumption. Here I'm publishing Edition 1. For any future additions and updates or revisions, I'll have to complete the export wizard again. To view my newly made E&C product in ArcGIS For Maritime server, I'll navigate to my server address after my file has been copied to a location that the server reads. In ArcGIS For Maritime server, I can search for my product based on its name. Once I've identified my product, I can zoom to its extent. As I zoom in, I can see more detail. I can select features in order to view their unique attributes. You too can view this data by copying the URL visible here and query the same data. Try it for yourself. To review, the workflow has been dramatically simplified for new product creation. Products can be published and consumed in a variety of ways, including ArcGIS For Maritime server. Now that the product has been created, it needs to be maintained. In this next section, I'll show editing the authoritative data in the NIS and creating revision files, or ERs. The authoritative data in the NIS needs to be maintained. The agency may receive updates in the form of notice to mariners, reports, or new surveys. New at 10.3.1 is the Checkout Nautical Replica tool. The Checkout Nautical Replica tool leverages ArcGIS technology and allows you to focus on a specific geographic area, such as an AOI, as well as a specific scale of data within that area. The data is copied from the NIS into a local Checkout Replica file geodatabase. You can edit the authoritative data with enhanced editing performance in a file geodatabase. If necessary, you can perform quality checks and validation in the replica database, including topology. You check your replica back into the NIS when your edits are complete. Now that you've updated the authoritative data, you need to update the product. To create an update or revision file, you use the same export wizard as with product creation. The revision file is created and stored in the product library, along with the original S57 file. You can then shore the update file via the ArcGIS For Maritime server, just like the base S57 file. In this next demonstration, I'll show how to use the Checkout Nautical Replica tool, how to make a simple edit within the replica database, how to check in the replica, how to use the export wizard to create the update or ER file, publishing the ER file, and then sharing the ER file with ArcGIS For Maritime server. Here I have data from my Enterprise NIS, and a definition query has been applied so that only 1 to 22,000 data is visible. To create my checkout replica, I'll need to select an area of interest. To do this, I'll select it from my product in the product library. Once the area of interest is selected, I launch the Checkout Nautical Replica tool. In the dialog box, I define my Enterprise NIS database. Next, I select an edit version within my NIS database. I define the scale at which I'm working. If necessary, I can use a custom extraction for a broader scale range, but at the moment it is not necessary. I define my checkout replica file geodatabase. And I rename the replica name. In this instance, I'm applying a notice to Mariner, so I name it as such. When finished, I run the tool. The NIS and Checkout Replica database both have the same schema. The only difference is the Checkout Replica has topology. Data is copied from the NIS into the Checkout Replica. Since the schemas match, there's no need to map the data or the fields. Once the tool completes, I'm ready to edit my Checkout Replica database. To do this, I'll need to open a new blank map document. In the catalog window, I'll navigate to my Checkout Replica database, select the nautical feature dataset, and add the data to my map document. As I mentioned before, my agency received a notice to Mariner. In this document, something has changed within my data. In this case, I have an obstruction. I copy the longitude and latitude of the obstruction and observe the attributes of the new feature. In ArcMap, I start a new edit session. In the Manage Feature windows, I select an edit template. In this case, I want to select my danger points feature class and my obstruction subtype in order to create a new obstruction. Once the subtype is selected, I can enter in the necessary attributes of my new feature. Once all of my attributes have been entered, I can use on-the-fly validation to apply the attributes to the new feature. This is adhering to the S57 International Standard. I could also save these options as an edit template if I was making more features with the same attributes. Next, I return to my map and zoom in on the general area of my new feature. Using a right-click context menu option, I can choose Absolute XY. Here I can enter the exact longitude and latitude that I copied from the Notice to Mariner document. My new feature is created at that exact point. Ideally, I would have several more edits to make in my checkout replica database. I would also have a quality control process to follow. For the sake of this demonstration, I'll skip this and move along to checking in my replica. First, I'll save my edits and mark my feature as verified, as though I had completed the quality control process. Once again, I'll save my edits and end my edit session. Now I'm ready to check in my replica. To do this, I'll need to use the Synchronize Changes wizard from the Distributed Geodatabase toolbar. In the wizard, I'll accept all of the defaults for Geodatabase 1 and Geodatabase 2. This was already defined in the Checkout Replica tool I performed previously. The Checkout Replica tool also made a temporary version of my edit version. Here, I'll want to reconcile and post with that temporary version. In this case, I want to define my conflicts based on object, since I created a new feature. And I want to resolve it with my checkout database and not my central database. When I'm done, the changes from my checkout database will be committed to the edit version I selected in my NIS. Now that my check-in is successful, I'll need to return to my NIS data. Here I've returned to the edit version of my Enterprise NIS data. I can zoom in and select the new obstruction that I previously created in the checkout replica, only now it's in my NIS. And there it is. If necessary, I could continue to quality check my data in my edit version, but for this demonstration, I'll move ahead and post my edit to the default version. I'll start an edit session in my edit version. Select the unverified feature. Mark it as verified and ready to be committed to the default version. I perform a reconcile, which compares the data in my default version to my edit version to make sure there are no conflicts. In this case, if there are any conflicts, I would want to resolve them in favor of my edit version. I have no conflicts. I'm ready to commit my edit to the default version. I use the Nautical Post tool, which checks to make sure my features are verified before the commit. Now my new obstruction is in my default version and can be used to be created for an update file. To create my update file, I return to the product library window. I select my product and choose the export wizard once again. In the export wizard, I define the dataset as an update. This will create my ER. I have the same location already defined, and I'll attach that Notice to Mariner file as proof that my update was necessary. Since my product is already created and being consumed, I'm very limited on anything I can change in the metadata window. Here my update file is being extracted from the NIS, created on my local machine, and zipped and placed back into the product library. If necessary, I can select and copy the log file to view at a later date to ensure that there were no errors during the update creation process. In the Manage Features window, I can view that my zip file has changed with a new timestamp and has my update file within it. In Windows Explorer, I can see my update file as well, .001. I can copy my 001 file into a new location and share it with Maritime Chart Server. First, I'll copy the update file into the location that ArcGIS For Maritime server reads. Next, I'll search for my dataset name as I did before. Once I find it, I can select it and zoom to it. As I zoom in, I see more detail, and I can see the obstruction I added with the update file. When I select it, I can view attributes about it and see that it is the same obstruction. If I create more S57 files, either new products or updates, the server will refresh and add the files. To review, the Checkout Nautical Replica tool lets you edit the authoritative data more efficiently, allowing you to maintain your products. You use the Export Wizard to create the update or ER file, which is created and stored in the product library. Lastly, you can share the update file with ArcGIS For Maritime server, just like you did with the base S57 file. In this last section, I'll review how to create paper nautical charts using ArcGIS For Maritime Charting. Creating paper nautical charts is very similar to creating electronic charts with a similar workflow. Let's take a closer look. To create a paper nautical chart, you'll still complete the new nautical product wizard. After the product is created, you run the chart automation tool. It automates and streamlines many steps that were previously done manually. These steps include adding data to the chart, arranging the drawing order and turning on labels, creating grids and graticules, creating cartographic features such as light sectors, converting labels to annotation, and when ready, creating masks for annotation. The human factor is still needed for some light cartographic finishing, as well as preparing the layout for printing. When it's ready, you'll follow the export wizard to create hard copy products like PDFs and TIFFs. Once the chart is exported, it's stored within the product library and can be distributed to others. In this last demonstration, I will show how to use the chart automation tool, how to make a few cartographic finishing edits, how the chart is arranged in layout view, and completing the export wizard with multiple output formats. Here you can see I've already made a paper nautical chart. I completed the new nautical product wizard and then checked out the paper chart to my local machine. The green checkboxes show that the product is checked out to me. I also opened the product map document associated with it. As you can see, no data is loaded in my map document. To get started, I'll need to run the chart automation tool. To access it, I'll launch it from the catalog window. Under System Toolboxes, Nautical Toolbox, Cartography Toolset, Product Library Chart Automation. Here, I'll select most of the processes, as I'll want to save masking my annotation at a later point in time. If I had other panels, I could choose to run the tool on all of them. In this case, I'm only running it on the main panel. Once I have my options selected, I click OK to run the tool. When the tool completes, I can see that it successfully executed every task that I chose. It added the data, created my grids, generated my cartographic limits, created my light sectors, and converted my labels to annotation. My data is now in layout view, and a pre-configured template was used when my chart was created. I need to calculate the symbology for all of my features. To do this, I'll pause my drawing, switch to data view, and select all of my nautical layers. Next, I'll access the Nautical Symbology tool, which allows me to apply cartographic representations to my chart symbols. The Calculate tool reads a pre-configured file that applies database-driven cartography. This means a feature and its attributes determine which symbol it receives. It's a pre-configured out-of-the-box file, but can be modified for an agency's deviation from the standard. Once the tool completes, I'll unpause my screen so I can view the results. Now that the symbology has been applied, I need to perform some light cartographic finishing. To do this, first I need to start an edit session. The warning message is just notifying me that the WGS84 data is being projected, in this case to Mercator. Then, I zoom in on a portion of my chart to edit some features. I need to address the symbol of my coastline. This is due to the direction the line was digitized. Once I select the feature, I'll open some representation editing tools. With the Representation Properties window, I can modify the representation directly. Here I'm using the reverse geometric effect. It flips the symbol for me. I can repeat the action for another coastline. Again, I'm only editing the representation or symbol and not the underlying feature. Afterwards, I'll save my edits. Next, I'll select a piece of annotation and move it for better visibility. I also have a navigation aid with a light. The light flare is overprinting the road. I need to select just the light flare so that I can rotate it. Once the light is selected, I use the Rotate tool and rotate it off the road. As you can see, other cartographic edits need to be performed. For this demonstration, and for the sake of saving time, they have already been completed. For this panel, only a few hours were spent on cartographic finishing. The cartographic finishing process includes placing annotation. Once this is complete, you need to run the final step of the chart automation tool. In the Chart Automation Tool dialog, I choose the option to create Annotation Masks for my main panel, and then I run the tool. When the tool completes, I can see the masks have been added to the map document. If I open the advanced drawing options, I can see that the layers have turned on for each mask layer. In this case, the depth contour annotation mask is masking several layers for better visibility for the depth contours. This is all configured in the Chart Automation tool and can be modified to meet an agency's needs. Here I'll zoom in to view the results of the masking process. Once I'm satisfied with the results of the masking, my chart is ready to be exported. I'll zoom to the full extent of the chart and then change to Layout View. Here I'm using a pre-configured template, which saved me time from adding notes and other surround elements, so that only a few needed to be modified for this specific chart. Next, I access the Export wizard just like I did with my electronic product. I choose whether or not I want to make an update or a new addition, the export location on my local machine, and whether or not I have any external files to attach. Next, I choose the output formats. First, I'll choose a TIFF. Once it's selected, I can change different settings, such as the DPI. I'll also add a PDF. Again, with the option to change the PDF settings. Just like with the electronic product, I'm presented with the metadata page. Since this is the first edition, I'm still able to edit some of the fields in the metadata. Once they've been changed I'm also presented with the summary page, one last chance to look over the metadata. Clicking Finish creates the actual files, the TIFF and PDF that I defined. They're created on my local machine, as well as zipped and added to the product library. Once the process is complete, I can view them in Windows Explorer. Here's my PDF and TIFF. I'm satisfied with my products, so I need to check in my product in order to publish it. Checking it in increases the version number in the product library, as well as updates the database and map document stored in the product library. Once it's checked in, I can then publish my first edition, just like I did with the electronic product. I select the new edition and publish it. Once it's published, it can be shared and consumed. To review the paper chart product workflow, you use the new Nautical product wizard to create new paper charts in the product library. Then, you use the chart automation tool to apply cartography to the paper chart. Next, you perform some light cartographic finishing. Lastly, you export to your desired hard copy format using the export wizard. To review this presentation, the Import S57 to Geodatabase Geoprocessing tool loads multiple S57 files into the NIS. The PL/AOI Loader tool imports the footprints of the same S57 files into the product library. This presentation also reviewed the new product workflow as well as the maintenance workflow. This included the Checkout Nautical Replica tool for editing the NIS. And lastly, it reviewed the paper chart product workflow. Before I go, I would like to point you to a few resources. You can request formal instructor-led training for more information regarding ArcGIS for Maritime Charting. The Introduction to ArcGIS for Maritime Charting course educates you on how to create and manage your electronic products. Cartography with ArcGIS for Maritime Charting instructs you on how to create and manage your paper chart products. As I mentioned before, please feel free to email your questions. I hope you enjoyed this presentation. On behalf of Esri, I'd like to thank you for your time. Goodbye.